Hello and welcome back to my RC channel. I'm Andy RC and today I'm doing another Betaflight video for a 210 sized Miniquad, starting off with this kit from Gearbest. Now the 210 sized Miniquad is a popular one, and I think that is because it strikes a nice balance between performance and practicality. So what do I mean by that? Well, the smallest quadcopter that I have built that takes a 5-inch propeller was the GB190. And it was a nice build, but it was a bit of a stressful build because you have to fit all of your components in these tiny stacks here. And the 210 has a slightly bigger stack, so I'm hoping that it's going to be a more relaxing build, but still able to take a 5-inch prop, which means that we can have the most amount of power from a small quadcopter like this. So let's see what you get in this kit first of all. Now it's at £188.68 at the moment, but it is on offer at the moment. So I'll put a link in the description to all of these parts that I have used. Check out the price there because it changes all the time. Also check in the description as well because I often put coupons and offers and things in there when they are available. So let's see what you get in this kit. So first of all, we have got the flight controller. This is the SP Racing F3 flight controller. It's a clone, of course, but I really like this flight controller. And then the camera, we have got the run cam. This is the FPV camera. It's a CCD camera. It's really high quality. And then for the antenna, we have got a SMA on-way antenna in red, which is a nice antenna. And then over to the VTX, again, a premium part. This is the Foxeer TM25 switcher. Switcher meaning that you can switch it between 25 milliwatts, 200 milliwatts, and 600 milliwatts, depending on your situation. Now, I am keeping all these parts pretty much. The only thing that I'm going to change out is this XT60 connector. It looks really weak there on this power distribution board. So yeah, power distribution board here with a built-in 12 volt and 5 volt regulator, really nice. But I can see that breaking, so it faces down so that you can attach your battery there and the battery cables don't get caught in the propellers. So I'm going to create a little pigtail connector here with some spares that I've got. I'm going to use 12 gauge wire and put a little pigtail connector up there rather than using this because I think that could potentially snap away this whole board here. So onto the motors. They are the Emax Red Bottoms RS2205 2300 kV motors. They have proved to be really good motors this year and very popular as well. Onto the ESCs, and they are DYS ESCs. They are 30 amp and they are Blheli S compatible, so they have that installed on them. And what I really like about these is they have solder pads here, so we can cut the motor wire short and solder them direct to the ESCs there, which is really nice. One thing I really like about the VTX in this kit as well is it's got this wonderful harness here, and it's got a 3-pin adapter that plugs straight into your camera. So all that you have to do with this setup is solder in the positive and negative wire into that 12 volt here on the power distribution board and you are good to go. Of course, remember to put the antenna on before you power up, but I really like that. I'm also going to change out the props because these look like a variation of the King Kong props, and in my cheap build that I did previously on the channel, they had a lot of vibrations on them, so I'm going to be changing those out and I will show you which ones I'm going to use in a bit. But really nice kit, this one. So we are going to need a receiver, so I'm going to be using the FrSky X4R SB. And of course the control system is going to be the Taranis Plus. For the battery, I'm going to be using the Dynegy 1300 4S 65 seat LiPo. I really like these. And then for the video goggles, now I use the Fat Shark Dominator V2 with a modded DVR with the super cap in it. You can't buy those anymore, though. The closest you can get to them is the V3, and I will also be checking out the HD3 soon as well, hopefully, see if they are a better upgrade for the HD2s, which I didn't get on well with at all. So there's no on-screen display with this one, but I am shying away from on-screen displays and more going for these buzzers. I've bought a load of these, so I'm going to be installing one. Of course, you need to connect the VBAT up to the flight controller, like I have done previously, and I'll show you how to do that. I bought a load of these here, just really cheap here. Now, how to know which one is the plus? They have a little sticker on here that says remove before washing. Not sure what that's about, but underneath there's a little plus. It's usually the longest side is the plus. These are usually of different lengths, even though they're not on the picture. Then really you get given a battery strap in the kit. However, I used this little tiny Velcro strap from Miniquad to strap in my HD camera, which in this case is going to be a GoPro Hero 4. So you can't attach a session camera to this very easily, or a Foxeer Legend or a Mobius form factor camera, which I'm sure we're going to see more of in the future. And then, of course, lastly, I'm going to be using the HQ Tri-Blade 5x4 3-leaf props instead of the ones in the kit. So that is the shopping list. Let's get on to the build. So starting off with the power distribution board, I'm tinning up the solder pads that I'm going to be using. The square pads are the positive pads, and the rounded off ones are the negative pads. They aren't labelled up there. So these are for the ESCs, the VCC, and also for the regulator. Then onto the frame, you're given these nice nylon screws, and the frame is recessed there, so they fit nice and flush. And I'm now putting the nylon nuts on there, and this is where the power distribution board is going to sit so that it doesn't short with the carbon. It's a nice design, this one. So just finger tightening those so the thread doesn't break on them. And then I've put the power distribution board down, and then I'm temporarily putting these standoffs in. This is for the flight controller to sit on. So this is the first motor going in. I'm going to be using all 4 of the screws. This is motor 4, it's the top left motor, and I'm using a hex driver to screw those in. Not using thread lock here, just tighten them up really nice, and you don't need to. So that's the first clockwise one. Now you see that logo, GEPRC? That's the front of the quadcopter. So the next one is also a clockwise motor. It's just the order they came out of the box that they come in, again using all 4 of the screws, and that is both of the clockwise motors in. And now onto the counterclockwise motors, again using a hex driver and tightening them up. And then the last motor is going in and making sure they're all nice and tight. So I'm removing these standoffs because I've realized I haven't put the battery strap in. This is something that you need to do early on because you can't access these slots underneath there. So I'm just going to feed this through right up to the buckle and then through the other side. And then you can put the power distribution board back on the top. And then I'm putting those standoffs back on. That's for the flight controller to sit on. So now I'm cutting the motor wires short. I'm not really being accurate measuring them. It's just about 1 inch. We have more space on this frame than recent builds. So just going to do that for all of the motors. And then I'm using this wire stripping tool to strip the wires back. It's an expensive tool, this one, but it saves so much time. Of course, you can just use a pair of cutters to do the same job, but I like this tool. Really nice and quick. So now that is done, I'm going to tin up all of the motor wires here. It's very important that you do this. I'm using an expensive hot iron here, but it doesn't really matter. You can use a cheaper one. And now I'm tinning up the ESCs. So in this build, I'm actually not going to remove the ground cable. It doesn't really matter. It depends on your preference, really. The ESC is already grounded to the power distribution board, so you don't really need to ground. Some people say that you'll get noise if you don't. I've never had a problem. I'm just being lazy in this build. I tend to find that it's a more neater job if you remove the ground wire when it comes to the wires, but there you go. So just tinning all these pads up here. You don't have to remove any wires, which is nice with these ones. And you can see this iron here, it's heating up the solder really quickly. I'm using it at about 400 degrees, which is really hot, but it makes the solder flow really nicely. So I'm just using a pair of pliers there, and the motor wires are getting soldered straight to the ESCs. And then I'll be using Blhelisuite later to reverse the direction. If you're interested though, having all the wires soldered straight turns the motors clockwise. So here I'm putting some heat shrink here onto the ESC. This is provided in the kit, and that's just so the solder pads aren't touching the carbon underneath because they are exposed. So now I'm removing this standoff here so it doesn't get melted by the iron, and then I am clipping short the positive and negative wire to the ESC, and then again using my wire stripping tool, and then I'm going to tin those two up. And then hold it straight with a pair of pliers, or you can use tweezers as well. So that's the positive in and then the negative of the first ESC. And then I'm putting that standoff back on for the flight controller. And then removing the next one. And again soldering the motor wire straight. Just using my finger to hold it down and just tidy it up if there's any blobs of solder in the wrong place. Again, using the heat shrink that is provided, cutting it down, and then just using a candle lighter to shrink it. It's probably best to use a heat gun, but I'm lazy, I like to use this. And now cutting those wires short again, and stripping them, and tinning up the wires. And then soldering them in. By the way, these ESCs come with these covers, like plastic covers. I didn't use them, so I'm just going to use some cable ties instead to save a bit of weight. So on goes the standoff again. Not too tight. And then onto the next ESC, just holding the wires in whilst I solder them. And on goes the heat shrink, and then heat it up to shrink it. And then I'm going to remove that standoff because I've forgotten, I don't want to melt it with the iron. So cut in the positive and negative wires shorter, and then stripping those wires, and then tinning them up. Same with the negative. And then just holding it into place, burning my fingers, and same with the negative. And then put that standoff back. And then removing this standoff. The worst thing is melting those standoffs. I really dislike doing that, so I try to remove them when I can. So in go the motor wires again, and then the heat shrink, just covering the ends there, and then heating up and shrinking it. And then onto the ESC wires again, just cutting them to length, and then stripping these wires and tinning them up. And then soldering in the positive and then the negative. This power distribution board is really good. They all line up perfect. And putting the standoff back on. So now I'm tinning up my XT60 connector. I'm not using the one in the package because I think it's going to snap off in a crash. So using this little pigtail here, just tinning up the negative and the positive there, and then pushing it through here underneath. So the battery's going to sit underneath this quad. Just let it rest in place there, and then solder it all in, making sure that the solder has flowed all around the pad and we have a nice join. So that's the positive going in, and then negative. Just using lots of solder and trying to get a neat job as possible. Okay, now I'm tinning up the JST connector that is provided in the flight controller kit. And this is going to go to the VCC pad, and this is for our VBAT. So it's the telemetry to the buzzer that I'm going to add. And then this is the positive wire to the VTX harness. Really nice harness with this VTX. It's already together, so just one solder. Then this is onto the positive 12 volt pad. And then this is the negative here. And then the camera is going to power off the voltage out of the VTX quite nicely. The only thing I'm going to do is remove the audio cable because the camera does not have a microphone. So that is the green wire there. I'm just going to use a knife and lift up that little pad there. And the wire should slide out. Just unravel it out of the harness. Really like this FPV setup with this one. So now I'm tinning up a negative wire, and this is going on to the 5 volt pad for powering the flight controller. This is a spare wire that you also get in the flight controller kit, and then I'm going to use any of the positive lines there on the flight controller. So I'm just going to solder that up underneath to try and make it a neat job. And then same with the negative, I'm just staggering them. You can use any of the negative pads there. I just like to stagger them so that they don't short or can't touch each other, should I say. And soldering that up. So next I'm organizing the ESC wires to solder them onto the flight controller. So that's motor 1 there at the bottom right, and this is motor 2 at the top right. And then motor 4 and 3 I can just move out of the way. This is just so I can measure it up, by the way. So I'm going to put the flight controller down for a second. So the USB is going to stick out the side. And I'm going to cut the ground and the signal short just so it can reach the flight control on the other side. And then stripping those wires, of course. And then this is motor 1, so I'm poking it through the bottom there and then pushing it down with my thumb to keep it in place, and then soldering the pad on there. And then this is the ground, so again just twisting it over the end, and this is why I like to cut the ground wires off so fiddly, doing 2. So this is motor 2 here, so it's the top right motor. That's the signal going in. Again, just press it down with my finger and bend it over. And then solder that in. Very fiddly, look at that. Just trying to push the solder onto the pad. And again, the negative feeding it through. You can solder them onto the top of the pads, but I wanted it to be a neat job, so it's a little bit more fiddly doing it this way around. So this is motor 3, so the bottom left. Need to cut that a little bit shorter. So in goes the signal again for 3, and then bend it over and solder it in. Again, very fiddly. And then this is the ground, so just bend it over and solder the ground in. Again, just pushing the solder onto the pad. And the last one, this is motor 4, so just cutting it to length again, unraveling it, and stripping the wires. And then feeding through the signal for PWM4, bending it over, and soldering it in. Same for the ground. So just checking there that nothing is bridged because it's easily done with this miniature soldering. And then onto the pad for the buzzer. So you're going to have to solder the buzzer underneath on this flight controller because the connector doesn't work, but the pads underneath do. So that's the positive and negative soldered in there, and that's the VBAT connection going in. That connector does work. And then the standoffs are going on the top here. and that is to fit the receiver. So there's 2 more standoffs at the back and then 2 nylon screws at the front, so the receiver can sit on the top there. So now I am removing the pins of the servo connector that comes with the X4R, and that's because I need to flash it with the EU firmware, so you have to switch over the positive and negative pins. Just use a knife to take those out and then push them in. And then the S port gets plugged into the receiver there. And then this goes into the bottom 3 pins of the Taranis. So I just removed my DSMX module, and that's going to go into there. So next, long press the menu button and page over to where the firmware is stored and select the EU version. So I've downloaded that from FreeSky's website and uploaded it to the Taranis. And then you should see a flashing light on the receiver as it writes the firmware. That takes a while to do, so I'll skip that on. Okay, once that's done, you can turn off the Taranis and unplug everything. We're not going to use that cable again. Okay, so now I'm going to set a model up, so go down to my empty slot there and create a new model. I usually skip the wizard and page over and create it manually, so I'm going to call this one GB210. And then the model image, I usually just select the TBS Discovery because it's one that I know is a quadcopter. And then I'm going to go to the bottom of this page, and we need to set the failsafe up to no pulses. So just move that along there and make sure that we are in D16 mode and using 1 to 8 channels. We don't need any more than that really. So now page over to the input screen, and we need to create a mode switch for our 3 modes: angle, horizon, and acro. So just going to skip that along there, and then under source you just need to select the switch that you want to use and move it into 1 position. So I'm using a 3 position switch there. Exit out of there and then page over to the output screen. It will automatically select the source as the previous one that you have just created. So I just put the mixer name as M because I'm lazy, I don't want to type mode again. So long press the page again, and now I'm going to select a arming switch. I usually set it as my 2 position switch on the back. It's the only 2 position switch on the Taranis, sadly. And so I've selected that. I can press exit. And again, page over to the mixer tab or outputs tab. And I'm going to change this to A for ARM. Again, it automatically selects the source. So long press page, and I'm going to select a switch for a beeper to go off in case we lose it. So I'm going to call that beep, and then under source, press enter, and I've got a 3 position switch here. I'm just going to move it into 1 position, and I'm going to set that up in Betaflight to beep in case the model crashes, and then again go over to the mixer tab and just create a B for the mix name. Automatically selects the source as beep, and we are done. So now I am taking this harness that comes with the flight controller, and this is going to be for our receiver. So we don't need any of the other wires. We only need the first 3 for ground, positive voltage, and signal. So we can remove the rest, and this is going to sit in the IO2, which is the output 2, which in this configuration, the way I've got the flight controller, I've got it set at a different angle, so I need to change that in clean flight, but this is going to go into the back JST slot. So just removing all these wires here. And then this goes into the bottom 3 pins of the X4R. Make sure that it's slotted in nicely. And then you can see there it just slots into the back here So the board is at a 270-degree angle here. I'll have to change that in Betaflight. So now I'm going to go into the menu here for the GBX210, and we're going to go into the bind function. Okay, so the Taranis should start chirping now. So I've got a screwdriver pressed down on the receiver and force a battery in there, and the light will start flashing to say that it's got a bind. So then you can unplug the battery and then come out of the bind mode in the Taranis by pressing exit. And then when you put the battery back in, you should get a solid green light on the receiver. At this point, I then make sure my switches are in the back position for the quadcopter being disarmed, and then I take the screwdriver and press the button again. The green light will flash, and that has set the failsafe position. Now, this is the harness for our LEDs, so we only need the ground and the voltage on the first two pins, and then we need pin 7 to control our LEDs, so the rest of them can come out, and this is going to sit in IO1 or output 1, and that is at the front of the board in this configuration. So just removing all of those, just using a knife and lifting up the pads and removing the crimped wires. So I'm just going to leave the red wire, which is on pin number 7. Okay, so we've got some excess connectors there, so just cut those off. And the same on the other side, they will just about reach the LED strip from there. So that goes in the front there, and I'm just measuring it up. I've put the LED strip in the back there just to make sure that it can reach over, and it does. So now I'm going to strip those wires again using my wire stripper. And then I'm going to tin up those wires. So this is pin number 7 for the signal, and this is the positive, and this is the ground, and then you've got the corresponding pads here. So you've got ground there, and then the signal, or known as DIN, and then the 5-volt positive pad there. So this is the ground going in, and then the positive voltage and the negative, and this is going to power off the flight controller. There will be enough power there for it to do that. So now I am taking some cable ties here, not the ones provided in the kit because you don't get given enough, and I am securing in the receiver to this little mount here, and that sits on top of those standoffs nicely. So these are my own cable ties, so just make sure they're nice and tight so the receiver isn't going to move, and make sure that it's as far back as it possibly can be so that it doesn't touch the LED strip. So just cutting that off there, and that's going to sit on the top nicely there. And then we've got some more nylon nuts to go over the top. So just tighten those by hand again, and the other side. Just going to push it forward a little bit as well, move the antennas out the way because it's very close to that LED strip there. Also see the buzzer just sits nicely underneath there too, out of the way. So now I'm putting the front standoffs in. You get these lovely, I think they're brass, or maybe they're just coated that way, but front standoffs are going in, and this is the way that I found to get this top plate on the easiest. So mount the front standoffs onto this frame, and then the back standoffs onto this top plate here. So you get given this little adapter for the VTX for the antenna coming out the back rather than that hole. And again, both of these link together with these screws here, and then these standoffs just go over the top there. So I'm just going to hand tighten those for now and then tighten them up a bit later with a hex driver. So that's the first one, and this is the second. You see that that top plate there nicely offsets the antenna, which is a really nice design. I really like this frame. So just tightening all that up by hand, and then this is the camera plate. So I'm just taking one of the screws that comes with the camera and then screwing it to this plate here. It's quite a tricky pod, this one is, but once you persevere with it, it's a really nice design. So that's the first screw going into the camera, and then the second one. Just using a screwdriver there, and then this slots into that top plate. Bit tricky. You have to push it down until it slots into place, but it's still loose at this point. So now we've got these brackets for your camera, your action camera, and that just adjusts there, you can see, and you've got this other standoff that goes between there for strength, and then another one of those screws links that up. So a bit fiddly, this, especially when you're trying to film it. So I'm just going to hand tighten it a bit and then use a hex driver to do the rest. And make sure you get it at the angle that you want, and I will be using the angle that faces most forward because I don't like to fly too fast. And then that's the other side going in as well. And then I have aligned the back ones up, and you've got another standoff that goes in there, and so I'm screwing that in. Again, using the hex driver. Like I say, it's fiddly, but it's worth it. So that's the last screw going in the back there. And just tightening everything up so that it doesn't move. And then our camera can get strapped in over the top there with some Velcro. So now I'm plugging in the VTX harness. This goes in nicely. And then also the camera as well, which also slots in nicely. No need to cut these wires to any length, really like that. And then the VTX goes over here like that. And then you want to use a cable tie there, and there's a little hole to secure that in place. Really, really nice. You don't have to do any modification here of this frame. Just slots together. It all just works. There's no messing around, you know. A really nice kit. So that's the first zip tie or cable tie, and this is one of my own cable ties here. So you are given 5 cable ties in the kit, but I used most of those to tie up the ESCs, which you'll see a bit later. So cut those off, and look how nicely that just sits there. Such a good design. So now I'm feeding the antennas through the top, and we'll be doing a solution for those shortly. So just feeding them through the hole there. And then I'm locking this now into place. This is fiddly because you've got that LED strip at the back, which also has to lock in like a little game of Jenga, but it can be done. So once that's locked into place, you use the last 2 screws to screw the top plate in. Again, using a hex driver, and tighten them up nicely. Also tighten the rest of them up at this point as well. And then we've got 2 screws for the underneath. Just look how packed in all that is. Just about fits, but I like it. And here we go, the screws underneath there as well. Just look how those nylon screws just sit flush underneath as well. Really nice design. Okay, so now I'm using my own cable ties again as a solution for the antennas. So these are thick, strong cable ties. I think they are 3mm. And that just sits around this gap nicely here. You can see that there's holes at the back for some straw antennas, but I don't have any of those spare. So I just like to use cable ties. So tightening those up nicely, and then one for the other side. See, they sit at a nice V angle. And then I'm measuring it up against the antenna and cutting it short because we don't need them that long. And then I'm taking some 6mm tubing and cutting that to length as well. And that's going to sit over the top of the antenna nicely. And then this is the other side going in as well. So just using my candle lighter, which needs some more juice in it, and that's shrinking up nicely. This can shrink up to 2.5 mil, I believe, from 6 mil, so not bad. And this is a really nice, neat build again. One of my favorites, I have to say. And then in goes the screw for the camera. Make sure you've got the right angle that you want. I'll be using the lowest setting because I don't like to fly that fast. The camera is still at a about 20-degree angle, however, so it's not completely flat. That's the other side going in. And then cable ties around the ESCs. Some people like to put sticky pads underneath. I've never had a problem not doing that. These cable ties keep them in nicely, I find. And then cut them to length. And you get given this anti-slip rubber pad for your battery, which I really like. I'm not including the carbon plate that you get for the battery because I don't find that you need them. So here we are in the Betaflight configurator. I don't bother with Clean Flight these days. You get this from the Chrome App Store. Now, I have already installed it on this particular flight controller, but I will show you how to do that nonetheless. So the quadcopter is plugged into the USB port via the computer, and then I'm going to go to the firmware flasher there, and we need to select SP Racing F3, which is already selected, and then the latest firmware, which is version 3.01. You then go to the bottom here and load firmware online, and it will download, so you need to be connected to the internet for that. And then flash firmware, but I'm not going to do that because I have already done it. If you are having problems with this, with it saying unable to connect, etc., I'll put a link in the description which troubleshoots those sort of things. It's usually a driver problem. But you can see there that it says COM3 at the top, so I'm going to connect to it here. And this is where you'd want to calibrate your accelerometer. Make sure the quadcopter is on a flat surface. It is not at the moment, so I'm not going to do that. I have already done that. If we go into the ports here, then I have got serial RX selected on the UART3. That is for our S-bus receiver. By the way, I'm in expert mode here, so it's a little button at the top that gives you your failsafe and lots of more options, etc. So if we go into the configuration tab here, got quad X set up, we've got one shot 125 here, I've got motor stop switched off. That means that when the arm switch is enabled on the transmitter, then the motors will spin up at the minimum throttle. So talking of the minimum throttle, I've got it set to 1033, and I set that up by going into the motors tab and seeing which lowest throttle setting would have the motors continuously spinning, and it was 1033. Maximum throttle set to 2000 there. Now, this part's important here. I've got the yaw sensor realigned to 270 degrees for having that USB port sticking out the side there. Very important. Otherwise, it won't fly in the right direction and you'll probably crash. So down here, I've got RX serial selected for our S-bus receiver. I've got the VBAT selected as well down here for our buzzer. I've left everything at the default there, and then S-bus needs to be selected down here as well. If we come down here, I've kept the PID loop frequency and gyro update frequency the same. Now this is important here because this quadcopter has an LED strip. You need to turn it on, otherwise it will disappear from the options there. So I've got that turned on as well. And you need to save and reboot for any changes that you have made in there. So for the failsafe, I've just got it to drop, which is the most safest option. And you want to make sure that you test that before you fly by plugging your battery in and then turning off the transmitter, and all of the motors should stop. PID tuning. Now, this one was an interesting one to tune, I think because it's very lightweight. It had unusual PIDs compared to what I usually select. So on the roll, it was 35 for the P gain and for the pitch as well. Otherwise, I got oscillations any higher than this, which is unusual. I can usually go up to as high as 60 and not get any oscillations. Integral, I set at the usual 4.5 that I set, and the D quite low at 30 as well, but it flew really nice on that. And the yaw is at 70 and the I 45 as well. I set my RC rate to 1 and the super rate to 0.8, which gives 1,000 maximum velocity of degrees, so that's how quickly it rolls basically. And that's everything on that tab. So of course you need to save it there as well. TPA, so it's just stock settings here as well. So for the receiver, we won't be getting anything there at the moment, and that is because you actually have to have a battery plugged into the quadcopter. So I will just do that now.
Welcome to Taranis.
Okay, my buzzer going off there. So now you can see there that we've got all of our controls there. You have to put the channel map to TAER1234, and that is pretty standard there. Now for the modes, I will just show you. I've got my arming on that 2-position switch there. I've got angle mode on the 3-position switch with horizon and acro, so you don't have any of these selectors in any of the range to get acro. So acro will come over here somewhere, so you can see there. Same switch, so we've got angle, and then horizon, and then acros over here, you see, with no slider selected, and that's how you enable acro mode. Get a little beep from that buzzer as well when you change the mode. And then down here you can see I've got aux 3 set as a beeper, so that's another switch, and you'll see what happens when I select that. And that is in case you crash, and if the battery stays connected, then you can use that to find the model in long grass. It is a really nice feature, that is. So you can also calibrate the ESCs at this point, but what I would do is now get the direction correct in Blhelisuite. So I'm actually going to disconnect from there and then load up Blhelisuite down here. And then connect. So you see it says COM3 there. You have to make sure that you're in the clean flight pass-through, and then connect to it. And then you have to press the check button here, and you can see there that I have reversed ESC2 and ESC3. So this one is going clockwise, and these two counterclockwise, and this one clockwise. So if we press OK there, you'll be able to see that. So this is Blheli S here. And what you have to do is unselect all the ESCs because it selects them all together. So I changed 2, so you can see there where it says motor direction normal. If we select just 2, it will say reversed. And then 3, it will say reverse. So you just have to change those and then write the setup. I've also got braking on stop switched on as well for all of them. So that's pretty straightforward. I like to reverse my motors this way so you don't have to mess around crossing the wires on the ESCs, etc. So now we have done that, we can actually disconnect from there. The ESCs will make a beep. You could actually calibrate your ESCs in this software, but I tend to do it in Betaflight because you can do it there too. So if we connect back to there and go into the motors tab now, we do need to calibrate our ESCs. It's important. So what you have to do is disconnect the battery and then wait for the Taranis to go crazy. You have to select this button here, and then we now lift this master up to full like that, and then plug the battery back in. Make sure you've got no props connected, and it'll get this tone here, and then we can drop this and they'll make beeps, and then this will calibrate your ESCs. There we go, we are done. So I'm just going to unplug this battery now, because the last thing that we need to discuss is the LED strip. So this is how I have set it up. I have configured them in 2 lines, just like they are on the quadcopter. And so what you have to do is go into the wire ordering and then click down here. So you've got 5 LEDs this way and 5 LEDs that way. Once you've done that, you can unselect there and you can select them individually. And the way that I have set it up is I have got these 3 LEDs here as an arming indicator. So if we just go into one of them there, you can see under here, we go into arm state. And then you can select the color there. So I've got it set to blue. So I did that for all of these ones, just a simple LED setup. And then for these top ones here, I've just got it set to color. And then I selected the color red. So these will always stay the same. Now there is a switch on this LED board, and if you flick the switch, it actually has an onboard programmer and then a button in the middle, so you can select between different flashing colors as well, so you don't have to link up the DIN if you don't want to, but I just wanted to get it all working. And I really like how when I arm the quadcopter, these lights turn from green to blue. I just really like it. So that's how I've got my LED set up, and that is how everything is configured in Betaflight and also Blheli. Next I'm going to put the props on, starting off with motor 4 there, and put the black nuts on the clockwise motor and the silver nuts on the counterclockwise, and the props are both facing inwards there, you can see. And then I turn it around, and again I have both of the props facing inwards, so the curve turns in the direction of the motor. So again, just hand tightening these nuts for now, so that I've got all the props on, and then using a socket wrench to tighten them up. These are locking nuts, so you can tighten them up right to the edge of the thread, and they will not come loose. So there's just one last thing to do before I can go and maiden this thing, and that is fit my HD camera. So I'm going to be using the GoPro Hero 4 here. Now you get given this little plate here, can you see? And this is the only part of the frame that I don't really like. And this is supposed to sit here. It's like a little gap. And it just sits loose. It sort of clips in there, but if you didn't place the camera on top of it, then it's going to come loose. So I've got my battery strap here, and I'm just going to tighten that up, and there we go. We are ready to go. So I'm going to stay in angle mode here first of all. I've got my arming switch here. Now I'm going to stand back a little bit in case there's any problems, like it's going to flip over or come at me. So the moment of truth. Pretty uneventful so far, so I'm just going to fly it around, see if there's any immediate issues that I can spot. Feeling okay so far. Let's go for the punch. Feels okay. Wow, really nice fly this. Okay, let's go for a roll. Seemed fairly snappy to me. Of course, you can't really tell until you do some FPV, whether you're getting any jitters or things like that. But feels okay to me. Nice and snappy. No jittering. Pretty happy with it so far. Let's look at this thing. It looks pretty cool, I have to say. Try and get a screenshot for us. Okay, let's come in for a landing and then go do some FPV. So this footage is taken from the FPV Maiden, so I fly around quite gingerly at first, just doing a couple of rolls. I'm looking for any tuning problems, and all is looking good. I'm getting good at tuning these quadcopters line of sight. Of course, I've done quite a few of them now. This footage just looks great, I think, and this quadcopter is just fantastic. From the start, it has been a pleasure to build. Just no problems along the way at all. Everything slotted together, everything just soldered in, and I didn't have to resolder anything or have to do any workarounds. It's just a really nice build, so I thoroughly recommend this kit and these components. They go together really well. One thing that I was really impressed about as well is the quality of the VTX. So it's a Foxeer VTX and it's really good quality. There's no breakup at all. There's no noise coming through from the motors. So this is going to be one of my favorite flyers, I think. So the flight time is really good as well. It's about a 5-minute flight time. I was getting over 5 minutes. And I think that's because it's lightweight, you know. This one weighs 590 grams. That's the all-up weight. So that's pretty light for a 5-inch setup, I think. And there's no vibrations coming through that GoPro whatsoever. It is rock solid. So I'll have to try a different camera on it at some point. I have got the Yi2 coming. So that should make for a good video, and I think I'm going to be using this quadcopter to put it on because it is rock solid. So you can hear the beeper going off slightly as I go on full throttle, and that is because this is a very old Dynegy pack. And just as I get to the top there, it's bottoming out. So what I'm going to do is I'm going to acquaint myself with this quadcopter a bit more, and then I'm going to give a full flight when I'm more comfortable with it. So there you go, that is my 210 size mini quad build. I hope you enjoyed this video. I'll put links in the description to all of the parts used, and I'm gonna leave you with some flying. So as always, thanks so much for watching. Please continue to subscribe. Cheers.
Take me away from home. Show me all the places I've never known. I will chase night, erase all of these broken dreams in flight, and we'll fly. Up here, we're free, bound only by frozen memories, lost in time, racing all these broken dreams tonight.